Hello everyone, welcome to our talk. Today I'll present duly noted layout-aware annotations with smartphone augmented reality. Despite the rise of digital reading experience, printed documents are still ubiquitous and constitute an important part of our document consumption experiences. From labels on snacks to covers on books, they're everywhere in our lives. However, printed documents are limited in its ability to update information or to share user-created annotations for multi-user experience. One potential solution here is using augmented reality to visualize additional information along with the printed documents. As a result, prior work found that AR allows for collaborative reading experience, providing updated digital information, and even facilitate online and offline discussions. Over time, researchers further found that augmenting printed documents with AR can lower readers' cognitive load on consumption, enhance workflows, improve engagement, and even learning efficacy. However, most of the findings were using a relatively less mobile setup, such as projectors or headsets, or using specialized hardware like digital papers that are hard to scale. This limits the number of users who can benefit from AR annotations on printed documents and potential applications in our everyday lives. Smartphone device is now ubiquitous and has a great deal of portability and conveniency for most users. It is capable to render digital information in situ with printed documents, and its wide availability made it ideal for multi-user annotations. However, prior smartphone AR annotation systems offer few insights on how to effectively annotate on printed documents. What lessons on interaction challenges or benefits for using a smartphone AR system to annotate? What needs to be done to make AR annotations more effective? To explore these questions, we're motivated to create a working smartphone AR prototype and test it with real users to understand the challenges and benefits for annotating printed documents. We start with using Unity Engine to prototype the AR environment, and using AR Foundation to perform the smartphone localization in the AR environment, and we used AR Foundation's image tracking library to track the document pages. We then use a common recasting interaction to allow users swiping on the screen to annotate on the printed document. With this prototype, we ran an experience prototyping to collect first-hand user information. This protocol entails users to directly engage with a functional prototype, thus providing real experiences. We recruited 8 participants for an open-ended highlighting and annotating task on 3 news articles within 30 minutes. Here, we list several benefits brought up by participants, such as enabling virtual annotation, revisiting experience in situ, preserving paper reading experience, creating non-intrusive annotations, enabling mobility with digital annotations, and sharing annotations among digital and printed documents. One of the most challenging parts for participants is to highlight accurately. Highlighting text often results in undesired location as shown on the red circle, or sometimes errors make it difficult to understand the intention of the user. These selection errors makes it hard to create meaningful highlighting and thus affecting later annotations. Annotations are also easily cluttered inside the smartphone's view. Here the red circles indicate the overlaps. Although users are given freedom to move annotations to anywhere they want, placing annotations too far away from the underlying text would cause issues in understanding. Another challenge is that annotation beyond the page becomes untrackable with the image tracking library. This happens often since participants habitually move the annotation to the margin space of the document. The results from experience prototyping informed the design of the interaction system duly noted. We formed the design goals from the benefits and challenges. The goal is to improve selection accuracy and shorten the interaction time, as well as finding ways to avoid annotation clustering. At the same time, automatically sync AR annotations to digital versions for further communications and editing. And finally, we want to keep all these running on an unmodified smartphone device to ensure maximum portability. To improve accuracy, You look at how do we reduce errors during the interaction process. When a user creates strokes, their movement naturally waves and swiping across the screen, causing some ambiguity in selection. If we know the boundaries of the underlying text, we may be able to better fit their strokes into the boundaries and form a final, accurate indications of where they want to highlight. This prompts us to consider document's layout structure to reduce the error. The layout structure enables users to further select sentences, paragraphs, or figures with one click. The image on the left shows the tab that selects the entire paragraph. The image on the right shows one tab to select the entire sentence. The layout structure further lets us group nearby text annotations. Annotations automatically shrink to save viewing space and expands once tapped. We explore annotation stacking on Z-axis so users can move their phone closer or further away from the phone to see annotations in different times. We use a server-client structure to allow real-time document structure extraction from printed documents. Please refer to our paper for details. Finally, we use a conditional tracking switch to reduce annotation drifting at document's edge. As the user moves their phone across the page, the red area indicates documents tracking. Once the phone moves to a point where documents is partially visible, the blue slam tracking is engaged to ensure that annotation does not drift. We run an empirical study to understand if it provides a more efficient annotation experience. We recruited 12 participants with convenience sampling. The results indicate that participants perform 42% faster on average, and were able to reach an average of 95% accuracy to select. Duly noted also significantly lower cognitive load. We further conducted an open-end session that collects qualitative and holistic views. Participants are presented with 15 pre-annotated highlights and were asked to read and reply to them. At the end of their exploration, we conducted a semi-structured interview with an exit survey. The exit interview and survey revealed that 83 participants preferred our proposed technique over the recasting as it being intuitive and satisfactory. All participants reported that they can read annotations clearly and did not experience cluttered view. Most of them are satisfied with the viewing experience and find it easy to navigate. Smartphone AR text selection can be challenging without additional support. Using documents layout structure helps users to achieve faster, more accurate selection results. Most participants find that duly noted interaction could be used for short-term interactions in everyday settings. Thank you all very much.